All right, just to give you a little bit sense on this next periodic table here, remember that everything in the first column has one valence electron, so it's easier to lose one than gain 7, which is why the first will always have a positive 1 charge. Second column has 2 valence electrons. It's easier to lose 2 electrons than gain 6, so it's going to have a positive 2 charge. So it goes positive 1, positive 2, and here we always skip all of these because they're a little complicated. And then here we are going to lose 3. 4 doesn't really have anything. Okay, 4s don't usually lose or gain. But with 5 valence electrons, you have the option of losing 5 electrons or gaining 3. Gaining 3 is a lot easier, so this one becomes negative 3. 7 over here, it's easier to gain 1 than lose 7, so it becomes negative 1. 8 is already there, so it doesn't need to do anything. So look at this pattern right here. Here it's plus 1, plus 2, plus 3, then you skip, then it goes negative 3, negative 2, negative 1. That's the pattern you should see on your periodic table. 1, 2, 3, skip, 3, 2, 1, nothing. Okay? All right, so moving on, let's draw our Lewis dot structures now that we understand about, or recapped about losing and gaining electrons. We know that lithium is in the first column, so that lithium originally has 1 valence electron. So I'm going to draw 1 dot right here. Now, easier to lose that 1 dot than gain 7, so we're going to say lose 1 electron. If that's the case, then that lithium becomes lithium with a positive 1 charge. Okay, magnesium works the same way. Magnesium normally has 2 valence electrons. We said it was easier to lose those 2 electrons. So then magnesium then becomes magnesium plus 2. Aluminum works the same way. It has 3, 1, 2, 3. It's easier to lose 3. So then aluminum now is naked and it has a positive 3 charge. So we see here on the right hand side that all the dots disappear, so we say that metals are always naked. On the non-metal side, we always say that they are stuffed. So for example, we know that fluorine has 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. Now, to get to 8, it's easier for fluorine to gain 1 electron. So if we do this, then we're going to put fluorine in some brackets and go 1, 2, 3, 4, 5, 6, 7. And because it gained 1, okay, I'll put it in red here so you can see it gained this 1 electron. Okay, so because it gained that 1 electron in the corner, we have to write it has a negative 1 charge. Okay, so we're going to do the same thing for oxygen. Oxygen normally has 6 valence electrons. 1, 2, 3, 4, 5, 6. To get to 8, it's easier for oxygen to gain 2 electrons. So here we're going to put oxygen in brackets and go 1, 2, 3, 4, 5, 6. And then we're going to gain those 2. So I'm going to put the 1 there and 1 there. So because it gained 2, we're going to say it now has a negative 2 charge because it gained 2 extra electrons. Right, 2 extra electrons is a negative 2 charge. All right, the last one is chlorine. So chlorine has 7. So 1, 2, 3, 4, 5, 6, 7. Okay. Actually, let's backtrack. Let's change this to nitrogen. Nitrogen has 5. 1, 2, 3, 4, 5. So instead of losing 5, it's easier to gain 3. So if it gains 3, we're going to put nitrogen and we're going to stuff it in some brackets. So 1, 2, 3, 4, 5. And let's gain 3 electrons. 5, 6, 7, 8, right? And so when we get to 8, we know that we gained 3 electrons. That's why it's a -3 charge. Okay? So if you know how to draw this top part, then now we know how to do the bottom part. So how do we draw Lewis valence structures for compounds? Well, it's fairly easy. Here, in my first example, I told you how many to draw. I said 1 atom of lithium and 1 atom of fluorine. Okay, that means that my lithium is going to lose 1 electron. Okay, and my fluorine, because these are the 2 examples we did above, we know it's 1, 2, 3, 4, 5, 6, 7. It gained 1 electron, so it has 1 electron gained. Okay, so the goal of Lewis structures of compounds is that you want to make this charge and this charge cancel out. Okay, so for example, lithium has a +1 charge and fluorine has a negative charge. 1 plus sign and 1 negative sign cancel each other out, so that means we're good. We want every compound to be neutral. So because they cancel each other out, they are neutral. So how do we write it on this side? We say that it took 1 lithium to cancel out 1 fluorine. So we write it like squished together, LIF. So lithium and fluorine, the compound, takes 1 lithium and 1 fluorine. Let's do another example. Magnesium and oxygen. Here I didn't tell you how many you have, so let's try to figure it out. We know that magnesium loses 2 electrons. And we know oxygen originally has 6. 2, 3, 4, 5, 6. And then it's going to gain 2 more, so it gained 2 electrons. All right, so now, question. How many magnesiums and how many oxygens will it take for my charges to cancel out? So, each magnesium has 2 pluses, and each oxygen has 2 minuses. So here, they cancel out here, cancels out. So now my compound is neutral. So now that my compound is neutral, how many of each did I need for it to become neutral? Just 1 of each. Therefore, it takes 1 magnesium and 1 oxygen, so you're going to write it like it's one word, to form a neutral compound. Now, it's not always 1 and 1, so let's look at an example where it's not. So let's look at aluminum. Aluminum is going to lose 3 electrons. So remember, if you need to, go back to your periodic table here and see what the charge of your elements are. Okay? Chlorine, if you look at your periodic table, normally has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. So to get to 8, we're going to gain 1 electron. So 1 electron was gained. So now let's do a count. Each aluminum has 3 pluses, but each chlorine only has 1 minus. Now, the first plus sign and the first negative sign cancel out, but we're still left with 2 of these pluses. It's not neutral. So what do we need to add to make it a neutral compound? We need to add more negatives. How many more negatives do we need to add? We need to add this one more to cancel out this, and we add another one to cancel out this. That is a total of 3 chlorines. Over here in my box, I only have 1, so I need to draw 2 more. So hopefully you left a little bit of space here because you need to draw 2 more chlorines. Now for every chlorine you draw, you do need to draw them stuffed. So I'm going to draw my dots. Okay, each chlorine is going to gain 1 electron. Okay, so we can see here the count matches up. So here, +3 and -1, -1, and -1 all cancel out to make a neutral compound. So how do we write that over here? Okay, for every 1 aluminum, it took how many chlorines? It took 3. So we write 3 very small. If there's not a number, it always implies 1. And then here we have 3 chlorines. It took 1 aluminum and 3 chlorines to create a neutral compound. Let me do one more example, and you guys are going to do the rest. So, here we go. Lithium loses 1 electron. Sulfur, I'm going to draw it stuffed here, has 1, 2, 3, 4, 5, 6 valence electrons because it's in the 6th column. So in order to get to 8, we need to get 1. Oops, let me try to draw it here. 1, 2. So we needed to gain 2 electrons. All right, so if we take a look here, we know that this and this don't cancel out. So this box over here is scratch work. It's not mandatory, but it is just scratch work area. So for example, I'm going to write the 1 plus sign, but each sulfur comes with 2 negatives. So one of these cancel out, right? But what do I need to create a neutral compound? I have an extra negative here, so I need another positive to cancel it out and become a neutral compound. That means I need another lithium. So I'm going to draw another naked lithium like this. So now, if I look carefully, my pluses and my minuses all cancel out. Now we're going to see how to write this. So how many lithiums did it take to make a neutral compound? It took 2. How many sulfurs did it take? It took 1. So that is our final compound. You have to make sure that these are written like it's one word, so make sure they are squished together. So, just a side note here, this structure up here, you have to know how to draw it. Must be drawn. This side over here is optional, okay? So I'm going to write optional right here. This is like extra scratch work, okay? But the Lewis structure, every time you see this word right here, you must draw it. You have to draw it on the quiz, and you have to draw it on your test, okay? On the next page, you're going to have some problems on your own, and then you can check it when you are done.